This is lesson 4.1a, a formula for slope. Our essential question: how can I solve real-world problems that involve the slope of a line? How can I calculate slope? How can I identify slopes of rising, falling, horizontal, and vertical lines? Our first question is, what is the slope? It is the rate of change. Slope can be positive if it looks like it's increasing from left to right, or negative if it is decreasing when you go from left to right. If it is horizontal, the slope is 0. If it is a vertical line up and down, the slope is undefined. And remember, with slope, it's the rate of change, so it's how much it changes in y over x. So that means like y for the y-axis is up and down, and x is left and right. So hopefully that will help us as we move forward. Looking at this first graph, I can see that it is going like this, which matches this one here. So it is positive. It is increasing when I go from left to right. It matches this one here, so we want to remember that this one is positive. We use m to represent slope, so m equals, so far I know it's positive. Then we pick 2 points on our graph that look like it is intersecting perfectly. So it looks like those two, and it can be any two on your graph as long as it's intersecting perfectly on the grid. So I could keep going. It looks like any of those points, any two will work. And then we need to draw a triangle to connect them. You can draw your triangle above the line or below the line. It does not matter. So I draw my triangle connecting the 2 points, and then I figure out the change in y as well as the change in x. Y is how much up or down, so it looks like it's going up or down 1, 2. And then on the x, that's left to right, it looks like 1, 2, 3. So then our slope is the change in y, so whichever number is showing me up or down, which is 2, over the change in x, so that's left to right, which was 3. So our slope is positive 2/3. So now on our next graph, we need to find 2 points where it looks like it's crossing nicely. So I'd say here and here. Alright, now we draw our triangle. Now keep in mind we need to figure out what the slope will be, whether it's positive or negative. And so if I look, this one is going this way, so I need to match the line with up here, which looks like it's this one, how it's decreasing when I go from left to right, it goes down. So this line's slope is negative. M equals negative. Now let's go ahead and figure out how much it changes when I go up or down. So from here, 1, 2, 3, 4. And then left to right looks like 1, 2. So then our slope is negative 4 over 2, which we can reduce to negative 2 over 1. That's because if you look, this point here actually goes nicely too. So my slope is going up 2 over 1, up 2 over 1, up 2 over 1. Or you could say down 2 over 1, down 2 over 1. Find the slope m between the following points: 4, 7, and negative 7, negative 2. Remember, when we graph a point, it's x, then y. And x tells us how much left or right. Left if it's negative, right if it's positive. Y tells us up or down. Up if it's positive, down if it's negative. Alright, so the first point, 4, 7. 4 is the x, so it tells me to go right 4 because it's positive. So I'm going to go right 4. And then 7 is where the y is, so that tells me to go up 7. Then we need to go -7, and we always start right here at the origin. That's 0, 0. So then I go left 7 because it's negative. 5, 6, 7. And then down 2 from this spot, down 1, 2. So it'll be right here. Then we connect the dots, draw our line, and then we draw our triangle between the 2 points. So from here to here. Then we count how much change there is. So from here, down, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the change on our x, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But then we need to remember whether it's positive or negative. This slope is increasing when I go left to right, so this is a positive slope. So our slope, m, equals positive, the change in y, the number that was up and down, which is 9, over the number that was left and right, which is 11. So our slope is positive 9 over 11. Next one, 4, -6, start at the origin, and 4 is where the x is. It's positive, so I go right 4, 1, 2, 3, 4, and then I go down 6 because the y tells me up or down, and it's negative, so I go down 1, 2, 3, 4, 5, 6. So right here. Next point is 2, 6. So I start at 0 and I go to the right 2 because it's positive, and then I go up 6 because that's where the y is. Y tells me up or down, and it's positive, so I go up 6 from here. 1, 2, 3, 4, 5, 6, right here. Then we connect the dots and draw our line. Now we draw our triangle from our 2 points here down to here. Alright, our line here, if when I go from left to right, it's decreasing, so this slope is negative. So our slope is negative, and then now we figure out the change. Up, down, so in y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then our change from left to right, 1, 2. When we write our slope, it's the change in y over the change in x, so that would be 12 over 2. Negative 12 over 2, which is the same thing as negative 6 over 1, or just negative 6. We actually have an equation that can help us find the slope if we know 2 of the points. So here I have 2 ordered pairs, x1, y1, x2, y2. One of the ordered pairs you just think of as 1, and then the other is 2. And then we plug it into the equation. So we write out the equation, m equals, we draw our line, and then we put a minus sign above and below. In the first spot, we're going to put y2, and then so it says y2 minus y1. And that's because that's the change in y. So that goes on the top, and then the x's go on the bottom. And so we're going to do x2 minus x1. So our formula for slope is y2 minus y1 over x2 minus x1. Alright, let's start on the back by writing out the slope formula that we just got. So m equals y2 minus y1 over x2 minus x1. And we're going to start with our ordered pairs for this first example here, using the first ordered pair as the 1s and the second as 2. So this is my first group, so x1, y1. Remember, in ordered pair, it's x then y. That's our first group. The second group, we still have x and y, except for it's our second group, so we're going to call them 2. Then we just plug it into our formula. Start out by writing the big fraction bar with the subtracts, and then we plug in. y2 is right here, so it's negative 2. Next is y1, which we have labeled right here as 7, so that goes here. Then looking back at our formula, x2 comes next. Here's x2, so I'm going to put negative 7 here. Next I need x1, so I look for x1, that's here, and it's 4, so I'll put 4 here. Then we just simplify top and then bottom, so negative 2 minus 7 more is negative 9. And then negative 7 minus 4 more is negative 11. But negative divided by negative is positive, so our slope is 9/11. Alright, our next one, the first ordered pair, so we can just start and do x, y, x, y. Let's just make that first group B1 and the second group B2. Now we plug it into our equation. Start by drawing the fraction bar with the subtracts. And now we just plug it in. y2 is first. y2 here is 6, so I'm going to put 6 right here. Next in our formula is y1, so we look for y1. It's right here, so negative 6 goes here. Even though we had that minus there for the subtract, we still have to write negative 6 because that's what the number was. Next is x2. So I look for x2, that's right here, so I'm going to put 2 here. Last, we look for x1, that is right here, so we're going to put 4 here. So then we simplify. 6 minus negative 6 is positive 12. Remember, you can use a calculator if you need to. 2 minus 4 is negative 2. So our slope is negative 12 over 2, or that we can reduce that to just be negative 6. If you want, you can write it negative 6 over 1. Here we have a line that is vertical, which if you recall from the front, that is an undefined slope. Next, we have a horizontal line that's running just left to right, which if you remember from the front of our notes, that tells us the slope is 0. Back in the 1990s, people had to pay for the internet based on hourly usage. There was a flat rate for the number of hours you were connected. The table shows the amount of time Wanda used on the internet for the first 3 months and the total she was charged. Graph the data and label the axes. So let's start by putting a title at the top, internet use, and then label the x-axis and the y-axis. So the x-axis I will label time. Specifically, it's in hours, and then the y-axis will be the fee in dollars. Now we need to graph the points, so x and y, because that's the axes they're on. Alright, so to graph the point, we go from 0 over 40, and then up to where about 16.5 is, so like maybe right there. And then the next point would be over 50, and then up to about 19.5-ish, like maybe right there. And I'm just getting the points, the ordered pairs from the table here. So you can just think of them as an ordered pair x, y, like that. Then the next point would be over 80, and then up to about 28-ish. Just doing about, doesn't have to be perfect. 28, so about here. Based on the graph, what is the approximate flat monthly charge that Wanda has to pay no matter how much time she spends on the internet? So that's referring to our time being, if our time is at 0, how much is it going to cost? So it would be somewhere in here. So if I draw my line, it looks like it would be hitting right about here, so maybe about $5. So to answer this question, $5. Now the next question says, what is this point called? That point right there is known as the y-intercept, which is also known as the starting value. Fred is scaling a steep incline. At 20 minutes into his climb, he is at an altitude of 30 feet. That seems like important information. So 20 minutes, 30 feet. At 45 minutes, he is at an altitude of 95 feet. What is the slope or average rate of change, and what does it mean? This word problem actually gave us 2 ordered pairs, 2 points. So 20 minutes, so I'm going to write 20 where I see minutes, and 20 minutes went along with the altitude of 30 feet. So altitude is the height, how far up someone is, so that would be 30 feet going there. The next ordered pair says at 45 minutes, so I'm going to put 45 where the minutes are. So this column is minutes, so 45, and then an altitude of 95 feet. So we can write them as points. And now to figure out the slope, we need the slope formula. And let's go ahead and label our two ordered pairs, x, y, and then one group as 1 and the other as 2. So let's write out the fraction bar and our subtract, and then we just plug it in. So we look for y2, which is right here, so 95 goes first. Next, I need y1, so I look for y1, that's 30, so that goes here. Then I need x2. Here's x2, it's 45, so that goes here. And then last, I need x1. So I look for x1, that's right here, it's 20, so that goes right here. So then we simplify, 95 minus 30 is 65. And 45 minus 20 is 25. And if we divide that, 65 divided by 25 in your calculator, we get 2.6. For our label, we can look and see 95 and 30 were in the altitude, which was feet. So the first part is feet. Feet. It's per. And then the second part, 45 and 20 were here, so it's minutes. Minutes. So he's climbing at 2.6 feet every minute. The Whomping Willow was 7 feet tall when it was planted in 1968. When Harry started Hogwarts in 1991, it was 40 feet tall. What is the rate of change, and what does it mean? So let's organize some of the information we got here. 7 feet in 1968. And first I have year written, so I want to use 1968 where the year is. And then the height, that would be feet, 7. And then in 1991, it was 40 feet tall. So just match up 1991 as a year, so that goes in the column with year, 1991. And then 40 is feet, so that goes where the height is. Now I would like for you to go ahead and try to solve this problem to figure out what the slope is, and then also what does it mean, so you need to make sure you have your label as well. So I'll give you some time to do that. So first you would want to make sure that you take the information from the table and write it as points. Next, label our groups x, y, and choose one of the groups to be 1 and the other to be 2. Draw your fraction bar with your subtract, and then we just plug it in. So instead of y2, I'm going to put what y2 is, which I have labeled as 40. And then minus y1, which I have as 7. And then x2, which I have as 1991. And then x1, which I have labeled as 1968. So if you chose the top ordered pair to be your 2 and the bottom to be your first group, that would be fine. You should still get the same thing as me, so let's continue and see if we got the same thing. So we simplify 40 minus 7, I get 33. Over 1991 minus 1968, I get 23. And if we go ahead and use the calculator and divide 33 by 23, we get 1.43. And then for our label, the top part, 40 and 7, were both height, so that was feet. And 1991 and 1968 were both years, so it's feet per year. So the tree grew 1.43 feet every year. And this concludes lesson 4.1a.